Bill needed to mix up some concrete for a project he was working on in his backyard. He did some research and found the following table to help him make a mixture of sand and cement that would produce a concrete strong enough for his job. Looking at the table, notice how the first row gives the number of pails of cement, and the second row gives the corresponding number of pails of sand. So if Bill uses 3 pails of cement, he needs to use 7 pails of sand. If he uses 6 pails of cement, he must use 14 pails of sand, and so on. And now we'll answer several questions based upon the table. A, we're asked what is the ratio of cement to sand? When writing a ratio, it's important that we pay attention to the order. This is asking for the ratio of cement to sand. So going back to the table, the ratio would be 3 to 7, or 6 to 14, or 12 to 28, or 15 to 35. We can write a ratio 3 ways as shown here, using a fraction bar, using the word to, as well as using a colon. We typically like ratios to be simplified, just like we like simplified fractions. So let's write the ratio of cement to sand as 3 to 7. And for part A, we'll write the ratio all 3 ways. 3 to 7 using a fraction bar, 3 to 7 using the word to, and 3 to 7 using a colon. It would not be wrong to give the ratio as, let's say, 12 to 28. Notice if written using a fraction bar, we can simplify a ratio just like we simplify a fraction. Notice how if we divide 12 by 4 and 28 by 4, we do get the simplified ratio of 3 to 7. For part B, how much sand would Bill need if he planned to use 18 pails of cement? Notice 18 pails of cement is not listed in the table. We can answer this question using a proportion. A proportion is formed when we set 2 rates or ratios equal to each other. Well, we know the ratio of cement to sand is 3 to 7, so we have 3 to 7 must equal, Bill wants to use 18 pails of cement, and therefore the second ratio would be 18 pails of cement to an unknown number of pails of sand. We form equivalent ratios just like we form equivalent fractions. Looking at the 3 and the 18, notice how 3 times 6 is equal to 18, and therefore if we multiply 7 by 6, we can determine the number of pails of sand Bill needs. Well, 7 times 6 is equal to 42, and therefore if Bill uses 18 pails of cement, he would need 42 pails of sand. For part C, how much cement would Bill need if he used 56 pails of sand? Notice here, we're given the number of pails of sand. We'll be looking for the number of pails of cement. So the ratio of cement to sand is 3 to 7, so we'd have 3 to 7 equals, the unknown ratio is the ratio of cement to sand. Here we're given 56 pails of sand, and therefore the unknown value here is the number of pails of cement. So we have an unknown number of pails of cement to 56 pails of sand. Looking at the 7 and the 56, 7 times 8 is equal to 56. So to find the unknown number of pails of cement, we multiply 3 by 8. 8 times 3 equals 24. If Bill uses 56 pails of sand, Bill would need 24 pails of cement. Next, how much cement would Bill need if he used 28 pails of sand? Looking at the table, notice how 28 pails of sand is given, and therefore we know Bill would need 12 pails of cement. Part E, what is the ratio of cement to concrete? Notice how the number of pails of concrete is not given, but we mix the cement and sand to get the concrete. So looking at the first column here, if Bill uses 3 pails of cement and 7 pails of sand, the number of pails of concrete would be 3 plus 7, or 10. Let's go ahead and list the number of pails of concrete in a third row. 3 plus 7 is 10, 6 plus 14 is 20, 12 plus 28 is 40, 15 plus 35 is 50. So going back to part E, what is the ratio of cement to concrete? Let's go ahead and use this first row. If 3 pails of cement are used, notice how this results in 10 pails of concrete. and therefore the ratio of cement to concrete is 3 to 10. And again, we can write this three ways, using a fraction bar, using the word 2, or using a colon. Again, we could have used any column, but using the first column does give us the simplified ratio. If we use the ratio of 6 to 20 or 12 to 40 and simplified, we would get the ratio of 3 to 10. Now for the last two questions, for part F, what is the ratio of sand to concrete? Again, let's use the first column so the ratio is simplified. And again, the ratio is sand to concrete. The ratio of sand to concrete is 7 to 10. For part G, we're asked what percentage of concrete is sand? Well, we know the ratio of sand to concrete is 7 to 10, and the amount of concrete gives us a total amount of the mixture, and therefore we can also say that 7/10 of the concrete is sand. So if we write the fraction 7/10 with the denominator of 100, we can determine the percent of concrete that is sand. Because 10 times 10 is equal to 100, and 7 times 10 is equal to 70, we know that 70% of the concrete is sand. I hope you found this helpful.